Welcome to the Derek Loudermilk Show. This is episode 363 with Dr. Robert O. Young. Dr. Robert Young announced the cause and the cure for cancer recently. He's the author of several New York Times bestselling books, including The pH Cure. He's worked with the U.S. Olympic team, Tony Robbins, Tom Brady, the Miami Dolphins, and he's truly an outside-the-box thinker. Many of the things that he discovered decades ago are only now beginning to be accepted by the major research institutions, like Harvard and Johns Hopkins, et cetera, et cetera. So I had the sense of being in the presence of a totally new way of thinking. It would like be sitting next to Galileo when he was talking about, the sun is the center of the solar system, and everyone's like, no, you're crazy. That's how dramatic some of Robert Young's theories are. So I had to put aside what I thought I knew from my textbooks, from my biology training, to really listen and understand how he's explaining the role of pH, the nature of the different organs and organ systems in the body, the function of the blood, and how, he even has seen platelets and different types of bacteria morph from red blood cells, which when you are looking under the microscope for decades and you start to see these things, well, then you have to form theories and try to understand what's going on. So that's what he's been doing for the last 40 years. And that's why these Harvard doctors are saying Robert Young has created an entire new way of thinking about biology that's going to revolutionize medicine. And he's also been carefully looking at what is happening in corona patients. And he and his team, his distributed team of other microscopists and scientists around the world, have looked at tens of thousands of vials of the corona vaccines. So he's going to share what he's seen in the infections and what he's seen in the vials. So if you want to know about health, this is a foundational episode for you. So without further ado, here is Dr. Robert Young. Dr. Robert Young, welcome to the show.
Oh, well, thank you, Derek. It's great to be on your show. Nice to meet you, by the way.
Thank you. Nice to meet you. Thanks for coming on. And I want to perhaps establish some of your credentials. We were talking a little bit about your education, but maybe the best way is for me to say, why should we listen to what you have to say?
Well, that's an honest question, and for some of you, I would say that you may learn something new, and if you can learn something new every day beyond whatever you've been educated in, that regardless of your educational level of education, you should always be in the mode of learning. And there's lots of different ways to learn. You can sit in a classroom, or you can travel around the world and literally experience that learning. So yeah, my areas of expertise in learning has been virtual, and has been being live and present in experiences. And I've always appreciated that, especially for my family, in teaching them, is taking them places so that they could actually see the world, taking them to Egypt, and seeing the pyramids, and going to the museums, going to London, and seeing the tower there, seeing not Uncle Ben, that's Rice, right? But Big Ben.
I think we can call him Uncle Ben.
Uncle Ben. I guess he's our grandfather or something. London, anyway. And I spent 2 years there, living there and experiencing life there. But so it's a variety of experiences, and I've really taught my children, to follow their passion. And for me, it was sport. It was being involved with amateur and professional sport up until the age of 29. And
What was your sport of choice?
It was tennis, yeah.
Ah.
And it's my son, said, "Hey, Dad, I want to thank you for teaching me tennis, because now I'm a pickleball pro." So
that's so funny.
So
my dad's plays pickleball like 10 times a week.
Yeah, well, he's a professional, and he's up there, and he says his tennis skills has made him, at least a better pickleball player. Of course, it is a different game than tennis, but it's great for people over 50, or even up to their 80s or 90s, because I call it dink tennis, but you kind of dink the ball over and back. But it can be pretty intense. My challenge with pickleball is just seeing the ball now. My mind is young, but sometimes my visual acuity is challenged. So, but I love sport. I love competition. I'm somewhat competitive, and but I've never really gone the norm. I spent my first year at the University of Utah, and then I went on an ecclesiastic mission for a couple of years. I came back and spent another year there under scholarship as a tennis amateur in one of the top ranked teams in the nation. And so some of the people I played tennis with and hung out with is like Roscoe Tanner and Stan Smith and Jimmy Connors, and there's others like that I could mention, but those are some of the few in the U.S. that people might remember.
Mm-hmm.
My coaches, Harry James and Jim Osborne. I mean, Jim Osborne played Wimbledon, but I did that professionally for some time. And when I retired, I was at 29, I was asking myself the question, what do I want to be when I grow up? So I don't know if you've ever asked that question. Maybe you're thinking, well, who wants to grow up? Let's just stay young and energy.
Well, you and I, it sounds like we had maybe similar trajectories. I was a pro cyclist, and pretty soon realized my natural talent wasn't going to get me very far. I was like in the lower half of talent. So that's, in my late 20s, I was like, oh, maybe I should go back to school. And that's when I went back for my microbiology PhD, which I ended up dropping out with a master's. But I was in Montana State doing research in Yellowstone in the hot springs.
Cool. Yeah, that's great. Well, I've always had a microscope, even when I was young. My first book was The Human Body. It was an anatomical book, and I guess it had some functionality in there too, but physiology. But that was my first book, and I've always been curious about how things work. But I lost that curiosity for music and for sport. I had a group that we traveled in. We were called the Simple Souls. I play the bass, I play the guitar, I play the drums. I sing, and my only fame to claim was doing a performance for the Queen of England. When I was in London, I traveled quite a bit in a music group. We were called the Family Portrait Singers in the early 70s, and I spent quite a bit of time entertaining people, and did some recording on Tin Pan Alley where the Rolling Stones. In fact, I kick myself now because a lot of their stuff was there, and I could have picked up a Mick Jagger guitar and all that kind of stuff. But I grew up in the 60s, and rock and roll was pretty lively back then, but I never did drugs. I wasn't into the drug scene. I was into being cognitive functionable, and really being in. I didn't want this out of body, loss of body experience. So I never did alcohol, never did any drugs of any kind, and it's still the case. I still have. I've never smoked, never drank alcohol, and never done drugs.
You tried any psychedelics?
What's that?
Have you tried any psychedelics?
No, none. No. So, to enjoy life, I don't know that you need to do that. And when you start looking at the blood and the effects of these drugs on the most important organ of the human body, you realize, for those who are doing it, I realize that it's not something that is healthy. So it doesn't improve the quality, let alone the quantity of blood. But my background, I became interested in. I was already interested in biology, and but it became greater interest, particularly in the work of Gunther Enderlin and his work. And I got connected with a scientist because I had international connections. I got connected with Dr. Marie Blocker. I can't even remember how we met, but I was fascinated with her because she was talking about a whole new science that didn't necessarily match what was being taught at school. And I'm always curious to hear what, the other side of this conversation is. And really what I was listening to at the time was I was listening to someone describe very clearly and then literally show that under a microscope, the whole terrain theory, and just literally destroying any illusion that there was a germ theory, that it actually had any significance. And over the years, of course, that has been solidified into my conclusions that germs do not cause disease, period. The germs are the manifestation of cellular breakdown or transformation. And so what you're looking at are things like endotoxins, and which are fragmented cells that are broken down that are being associated with germs. But I then realized that through my studies with indirectly with Enderlin's teachings, that things can change. There's not like a cat and dog. There's no specific germs. There's just specific environments that can cause evolutionary transformation of matter, and that's what gives rise to these things we call germs. And so, yes, there are rods and round bacterias and yeast and mold, and these are just different stages of evolution of cellular transformation. And they appear as an effect rather than a cause. And so that became very important to me because I really wanted to understand the cause and effect relationship. And that really is not understood by most scientists or biologists in the world today. Unless you're a marine biologist, then you understand it perfectly. Because they realize that what the fish are swimming in is, if it alters biochemically, that everything changes and dies. And somehow we have lost that particular concept, that the fish are only as healthy as the water they swim in. And if you take that to a cellular level, that the cell is only as healthy as the water it's bathed in. And I think the guy that has come after some of my work is Bruce Lipton. He wrote a book called The Biology of Belief.
Yeah.
And you have to honor guys like that, because they're stepping outside the box, saying, hey, it's not about the genetics, it's about the epigenetics. And what I just said here is, it's not about the cell, it's about the environment in which the cell lives in. And so genetics doesn't determine your destiny. It's the environment of which those cells are found on determine the destiny. And germs are just the effect of, or an expression of, a polluted environment. And when you clean up the environment, then guess what? I think I would side with the Nobel Prize winner for medicine, when he won the Nobel Prize posthumously, he discovered the life of a human cell. And he determined it was infinite. That cells don't die, they change based upon their environment. So what he did was what is called the chicken heart experiment. And he was able to keep the chicken heart alive indefinitely. In fact, there's a test going on right now with a pig's heart. Could be a cow's heart, but anyway, a heart at the University of Minnesota, and they're keeping this heart alive, this pig's heart alive, and they're doing it by changing the environment and managing the environment in order to do that. So the heart lives, the chicken heart lives, and he received a Nobel Prize for his discovery on keeping organs, tissues alive for transplantation. How do you preserve an organ? You have to stabilize that. Same thing like we do with the food we put in the refrigerator. Someone might say, well, why do you put food in the refrigerator? To control the environment. Well, the body, theoretically does that kind of for you, but I mean, you just can't neglect it. Just like you got to take care of your car, you got to take care of the oceans of your body. So that's why I have this picture behind me. But anyway, that gives you a little background of where I've come. I mean, I just jumped from the 60s to the 70s to the 80s. So there's a 30-year span that goes on from there. So I've been around for, over 70 years.
Yeah. So let me just see if I can recap some of the things that I want to come back to. I want to understand more the difference between the germ theory and the terrain theory. I did a little bit of work on the Great Barrier Reef in marine biology. I lived in Australia for a while during my undergrad and studied marine biology. So I totally know what you're talking about in terms of the aqueous environment. So I think what you're saying is it's so important to understand the aqueous environment around the cells in our body. Mm-hmm. I know you're big into the pH, but I'm sure there's all kinds of other metabolites and things that are in that intercellular space that are probably understudied and under discussed. And then also, just love hearing, about some of your travels, playing for the Queen, going to Egypt, into sports. I can appreciate understanding that part of your personal history as well.
Yeah, well, one of the things when I went to Egypt, I brought back some of the microzymas, or the dust of one of the pharaohs, to study under the microscope. And my reason for doing that is I wanted to show that I could bring it back alive.
Did you
that if I put it back into its environment, just like a seed, it will sprout. So nothing ever dies. It just changes its form and its function. So that information in the dust of a human after decay is still intelligent. And there's still memory there. It's encrypted on the anatomical elements. In fact, just on one red blood cell, you can decipher a whole life from that. You just have to have the player to be able to put the blood into, to be able to literally take every thought, every word, every deed that's been expressed in that lifetime. It's all recorded on these anatomical elements. And I believe, that what we'll have is not computers necessarily with hard drives. Just one drop of blood will encrypt. It can receive and transmit, just one drop of your blood, all information, any information.
And are you saying you have that ability? Like you could look at a drop of blood and tell someone all about their life?
We don't, well, I got ahead of myself on the blood per se, but no, I'm talking about the anatomical elements that are left, because that's what I want people to know. The blood is not living. It's the anatomical particles. Béchamp called these microzymas. I learned them learned these anatomical elements and saw their life, their little specks of light that are bouncing around.
Anatomical elements. Okay, what? So
it's a living, indestructible anatomical element that after the body's been cremated, there is a material. That material that's put in the urine, you can burn that and burn it. It's not going away. So that material is alive. You can reconstitute it back into a saline solution, 0.9% saline solution, and you can see it come alive.
What is it made of? What is the?
It's made out of indestructible material. It's living, indestructible material that's the precursor to genes, to cells, to organs and glands. It's the only thing left after complete decay. When you read the book, The Blood, the third anatomical element, you have red blood cells, white blood cells, and then you have that material that makes up red and white blood cells. Because when there's conception between a sperm and an egg, one drop of blood forms, and out of that one drop of blood comes all other body cells, all other organs and glands out of one drop of blood. But that blood is made up of what Antoine Béchamp called the microzyma. If you translate that from French, it means small being. He called it the only living thing. You could take 100,000 of those small entities, put them on the tip of a pin, and they would stay in place. So when we're seeing cellular breakdown or Brownian movement, what we're really looking at is the primordial life of the beginning and the end. So when I'm looking at this, I've literally got my finger on the magic of life. I'm looking at red blood cells, but that's a larger manifestation of billions of these anatomical elements that have joined together in an organization that has the ability to change its form and function based upon the environment. So in 1994, in a type 1 diabetic, I witnessed the biological transformation of a red blood cell into a rod bacteria. And out of that rod bacteria had the same dimensions and anatomy of what would be identified as an Anthraxis bacillus. But then something very interesting happened. Had I, at the moment, looking under the microscope, just saw the anthrax bacteria in the blood plasma, in the vascular fluids, and then I watched this transform into a red blood cell, would that be significant?
So you saw it change and then change back?
That's correct. Yeah. So that 1994, I couldn't explain that. It definitely didn't represent anything like the germ theory, that its species are genetically, perfected. It is what it is. Like a cat is a cat and a dog is a dog. And cats don't morph into dogs, right? Just as monkeys don't morph into humans, unless you believe in some sort of, transformation that takes place within species. Yeah, I believe in evolution within the species, not outside the species. But if you take a chimpanzee and you take a human, they're made up of the same stuff as it relates to the anatomical element of the microzyma. The only thing that makes them different is within the soul that resides within them. And that's a matter of intelligence. That's a matter of light. So what I saw in 1994 is I witnessed in a 21-year-old type 1 diabetic who was on a junk food diet. She was definitely on a diet, not a live it, because she was killing herself with coffee and hamburgers and junk food, fast food. Taking 120 units of insulin a day, trying to keep her blood sugars down because people don't realize that sugar is a byproduct of cellular breakdown. It's a waste product. kind of like bananas get sweet as they're breaking down. That's what happens to human matter. It gets sweeter and sweeter and sweeter. So you don't get old, you mold, I say. But mold is a biological transformation of the microzyma. What used to be an organ can transform into aspergillus or fusarium. These are just different forms or structures of cellular breakdown. And people get, when you're in the germ theory, this is not possible because there's genetic issues, how does that change? But it's all pH sensitive. So if you're actually watching, and I have watched it, I've watched blood turn to bacteria, turn to yeast like candida. I literally watch it push out Y-form yeast, where it started out as a red blood cell. So when you see this, you question everything that you've learned in microbiology, because it's not static. Matter is constantly changing. In fact, if I could say one thing about that, the only thing in life that is constant, and this is a matter of physics, the only thing in life that is constant is change. So you have to get used to it. You have to realize and look forward to the fact that we're always changing. And that changing depends on how well we take care of the internal environments of our body. And that's the basis of my disease and health model.
Okay, so I want to go back to the microzyma. What is that? Is it the term?
Yeah, well, Enderlin called it the protete, and Gaston Naessens called it the somatid, and Dr. Livingston Wheeler called it the progenitor cryptocide, and then Antoine Béchamp he referred to, which was the first in a line of many others that followed him, in French, called Microzyma. And one of the most important books that he wrote is called Lace Microzyma, where under his microscope, he didn't have a digital camera taking pictures, but he would draw what he saw. And he literally draw what I just described to you, the evolution of matter, or I call it microzymian evolution, from the beginning to the end and everything in between. So there's different manifestations, but it begins, as God said, from dust. It ends with dust, and that dust cannot be created, nor can it be destroyed. The only thing it can is organize or disorganize. That is the only thing that's living in the human body, other than the spirit that inhabits that particular tabernacle. But when we're talking about physicality, the only thing that's living is the microzyma. Genetics can only alter, even if you're injecting it, synthetic-wise or not synthetic, modified or not modified. The only way it can alter, is your base, is if there's a change in the environment. If you're controlling the environment, it's toxins in, toxins out, as long as the orifices are open. So, with the idea of using mmRNA, to manipulate the genetics for whatever, or to create spike proteins, it's all a fairy tale.
I want to go back to you said after the cremation, that's what's left. And I would expect that it would be just like carbon dust or something like that. Just like raw atoms. What do you see when you look under the microscope at that dust?
At that dust, I see it bouncing, moving. It can also collect. It can form and aggregate, but it becomes alive once you put it in a specific environment. So, especially the environment that it was realized in, or it was birthed in, and that's that alkaline environment at 7.365. in a saline solution of 0.9%, 0.9, just under 1. And when you do that, you can take your grandfather's or your father's dust, if it's been cremated, a little bit of that, put it under, a cover slip with a slide. At first, you have to put it into saline solution. And then once you've mixed it, put that in on the slide, seal it. And then using phase or dark field, you'll actually see the life. It's alive.
And you can tell it's alive because it's moving in a coordinated
It's
manner?
moving, it's organizing. It has direction and purpose. And so a little bit different than just an atom of carbon.
And is this so one time I visited the 3M incinerator, and they would put all the toxic waste in this incinerator. And the guy was telling, so it was the guy that managed the incinerator. And he said, if you get it right, it just fuels itself and it keeps its temperature up. But the only thing that comes out is the raw atom. So you can take the toxic medical waste or the chemical waste that the 3M plants have generated and just put it in there, and it's just clean, raw atoms that comes out as the waste.
What's the temperature burn? What did you have the temperature at?
I feel like it was maybe like 2,900 degrees.
We're talking temperatures 5 to 10,000 degrees. You cannot kill this. You cannot destroy it. Gaston D'Estran tried to destroy it with diamond cutters. You can't blow it up. You can't burn it up. You can't burn it. I'm talking about living matter from a body. I'm not talking about some, element from the periodic table. I'm talking about your flesh, which has intelligence.
Is it made of atoms? What is it made of?
Sure. It has to be. Yeah, it has to have carbon in there, but the material itself, how do you analyze that? I mean, yes, you could use an energy dispersive X-ray spectrometer, to try to look at this thing. But yeah, here again, it's down in the nano range. Yes.
Huh. Okay. I mean, I feel a little bit open to this, but also still wondering how. I'm still trying to wrap my head around this idea, and I feel like I sort of expected you to say various things throughout this interview, and me to be like, okay, I want to believe that, I want to understand that, but it seems like a stretch for me at this point.
Well, you need a microscope, don't you?
So you seeing is believing, obviously.
Absolutely. I mean, you can talk about this, but when you actually witness it in a living human fluid, when you're looking at it and seeing these biological, I've taken videotapes. You can go to YouTube and watch these biological transformations. There's over 40 videos of this. Of course, I discuss it. But yeah, you just go to Dr. Robert Young on YouTube, go to playlists, go to live and dry blood microscopy, and you can see the biological transformations. But what you're looking at there is you're looking at larger, micron size entities, because blood is approximately 7.5 microns in diameter. You're looking changes, and some of those changes can go up to 20, 30, or 40 microns, and they can reduce in size. I see them just shrivel up and then push out a yeast form. And that yeast form may be 1 or 2 microns, or it could be 4 or 5 microns. It's like it's giving birth to a whole different form. And you can see just some of these particles literally dissemble, and now they're in the vascular fluids, or the fluids that they were contained in when taken from the blood, and you can see them kind of moving around. So actually seeing is believing.
Have you shown this to other sort of skilled microscopists and had them sort of
Well, yes. I
realize
mean,
you're on the right track?
yeah. I mean, I've been taking pictures, micrographs since the 80s. I remember my experience talking to a professor of hematology at the University of Vienna, and I showed him biological transformation of red blood cells into bacteria and then back again. And he said, in the 20 years I've been teaching hematology, I have never seen what you just showed me. And he had the same reaction. He said, well, you know, these phenomenons that are taking place, apparently they happen. We're just not aware of them.
So why didn't he see them? Or what, is it because you got the conditions right?
Well, you have to be looking at them on a daily basis. And I think you have to happen onto it. It's kind of like you don't notice a particular car or a brand of car until you buy one yourself, and all of a sudden everybody's driving it. You know, and you kind of you kind of say, well, geez, I didn't know, well, he's got one, they got one, and everybody's got this car. I thought it was unique, but it's not. Once you see it once, then you know what to wait for. You can see it. So if you're looking at a codicide, a red blood cell that has a hole in it, in other words, that red blood cell has lost its hemoglobin. You're looking right through the cell. And you know that membrane is going to biologically transform. And that's what happens. So the membrane is where a lot of the intelligence, people think it's in the mitochondria. No. Red blood cells are the primary stem cell. They have intelligence. Their intelligence is in their membranes, which are made of these microzymas, and they know exactly how to form. They can construct and deconstruct depending on the environment. They evolve. I've watched them give birth to platelets. Platelets are not specific. They're not like red blood cells, white blood cells, and platelets. No, everything is a product of the blood. So when you're looking at a liver, or you're looking at a heart, you're looking at bone, you're looking at platelets, you're looking at bacteria, they're all a product of the blood. And the blood is a product of the microzyma. And one of my other discoveries is that blood is only made in the bone marrow if you're starving to death. So if you're going on a fast, or, and you're not eating, then the body will start going into what is called reverse transformation and start producing blood out of body cells. I call it reverse transformation. Mm-hmm. So the primary site of blood production is in the crypts of the small intestine. That's where the erythroblasts, the primary stem cells for the red blood cells, are made. And then from there, they go into circulation. And people don't realize that they de-differentiate and redifferentiate, that muscle is made from blood, hearts are made from blood, liver is made from blood, bone is made from blood. And you kind of get it if you're looking at a 9 to 10 to 11 week fetus, and you can actually see the stages of transformation that's going on as core blood from the mother is being transformed into various organs and glands. And once you understand that blood is the primary stem cell and the quality of that blood, and there's another way to test that is when you change the quality of the blood and start improving the quality of the blood, then every organ and gland and tissue starts improving. So, you could say, well, that's just a casual effect. This is, well, no, it's measurable. And then if you're testing the interstitial fluid and you're seeing that the person is in decompensated acidosis, or like your example of where you were working in Australia, or where the coral reefs are.
The reef die off, yeah.
Yeah. The question in my mind is, why is the coral reefs being disintegrated? And the answer is to maintain the delicate pH balance of the ocean. And it's no different. The ocean pH is 8.3 to 8.4. The ideal pH of your interstitial fluids, which are the fluids that surround the cell, are 8.3 to 8.4. And when that pH goes down, you start losing bone and muscle. And the reason why the coral reef is being deteriorated is because we're polluting the ocean.
And it's using the ions from the coral to.
Yeah, it's called
buffer that?
hypercalcemia. So the ocean goes into hypercalcemia. You have a loss of the coral reef, no different than we're seeing in every case of sickness and disease, particularly cancer. One is in hypercalcemia in the interstitial fluid, which is 80% of the extra fluids, why the blood vascular fluids are normal. So the calcium ion levels are within the normal range. They're out of range because the body, i.e. the blood, has to maintain its delicate pH 7.365. It's out of range it's normal in the blood. You're in hypercalcemia in the interstitial fluid. And this is where you end up with arthritis and osteopenia and osteoporosis, and your bones are being used to maintain the alkalinity of the blood to keep you alive. It's a very perfect system, but if you're not looking at 100% of the fluids, then you don't get it. So medical doctors don't get it. And the reason why they don't get it, because they're only looking at 10% of the body fluids, which are the vascular fluids, and they're not testing the biochemistry, of the interstitial fluids, so they're missing the whole show. Literally missing the whole show. And so they're not going to see the coral reef being dissolved. They're just going to looking at a symptom and call it a disease when it's really not a disease. It's a symptom of acidity that's been compromised by lifestyle. What you eat, what you drink, what you breathe, what you feel, and what you think, and what you feel and what you believe. So rather than correlate disease as a thing or as a noun, there is no disease. Disease is an illusion. There's only balance and imbalance. And if you don't test the ocean, then you're going to lose the coral reef. If you don't take care of the acid rain, then you're going to lose the forest in Denali, which is happening. It's called acid rain. And if you want to lose your bones and muscles and wonder why you think it's a disease, you're in fantasy land. You're hallucinating. You're losing the bone and your muscle to maintain the biochemistry to keep you alive. The body does that on its own, in spite of your perverted or inverted lifestyle.
I had a teammate of mine, and he, I guess, wasn't getting his electrolytes right or something. And he was a young man diagnosed with osteoporosis. And I think what was happening was the calcium, he was using the calcium because he was sweating out so much that it disrupted the pH or something. And then he had to take that from his bone. So it was weird to have such a young guy with osteoporosis.
Well, that's a beautiful example. So what is he sweating out? Okay, well, the skin has pores, 3,750 per square inch. I call it the third kidney. Okay, so what is he sweating? He's sweating out lactic acid. The bone is being wasted to maintain the proper alkaline pH of the interstitial fluids in the blood so you don't die. When people are off the road on a marathon throwing up, they're throwing up acid. That acid is caused from is a metabolic acid. So it's uric acid, it's lactic acid. Okay, they're throwing up. Well, why are they throwing up? Because the stomach is the major organ of immunity. The stomach produces a compound from its cover cells that produces sodium bicarbonate. The reason the stomach is producing sodium bicarbonate is to neutralize the lactic and citric and uric acid from overexercise, and you're ending up with a belly full of hydrochloric acid because in biochemistry, it takes water, salt, carbon dioxide to make baking soda, which is sodium bicarbonate. The exhaust of that, the waste of producing sodium bicarbonate, is a highly toxic, at a pH of 1.5, a highly toxic acidic waste called hydrochloric acid. It's a poison. It's so poisonous, the body pushes it out into what are called the gastric pits. It never sees the light of day. And if it starts becoming excess because an athlete is over exercising or exercising beyond its capacity to neutralize a poison, which is lactic acid or citric acid or uric acid, to preserve the life. So the runner's off the side of the road throwing up hydrochloric acid. And yet we find these in all our medicinal, our pharmaceutical, and our nutraceutical supplements as if we need this acid for digestion. I mean, it's totally crazy from my perspective.
So the common perception of the stomach makes acid for digestion, you're saying it's the byproduct because it's making the bicarbonate.
Yeah, well, if that was true, then you could eat corn, swallow it, and it would come out liquid instead as a whole kernel. The stomach doesn't digest anything. That's another scientific myth. The stomach's purpose is to manage and maintain alkalinity. What I can advise you to read my article. There's 25 scientific points. I've published these. Changes everything. In fact, Neil Solomon said about my work that the work that I was doing will change the medical and biology worlds as we know them today. It blows up everything that most people say. I had one doctor come to me and says, well, after I spent a couple of weeks with you, you just blew up 14 years of schooling in about 2 weeks. And he says, you're right. Once you understand the aspects of this, you understand the stomach does not digest food. The intestines do not digest food. This idea of taking probiotics and enzymes is not scientific. The stomach's purpose is to produce sodium bicarbonate to alkalize the food, to bring it up to a pH of 8.4, because if you want to make healthy blood, it has to be in an environment of 8.4. There's two ways the body heals. It either scars or it regenerates. It scars in pHs of fluids at 5, 6, 7. It heals and regenerates at 8.4 to 9. But 99% of the world's population is in decompensated acidosis of the interstitial fluids of the largest organ of the human body, which is called the interstitium. I learned it in Germany over 40 years ago as the colloidal connective tissue of the shod. Enderlin taught me this. Marie Blecker taught me it's about the environment, folks. It's not about the matter. It's the environment which that matters from. Isn't that true with the food in your refrigerator? Isn't that true with the fish in the ocean? If you adjust the pH of 8.4 down to 7.9, as a marine biologist, what happens to the fish and the coral reefs and everything living in the ocean if the ocean drops to 7.9?
You probably killed a lot of stuff. Yeah.
Everything dies. What happens if your pH of your blood fluids drops from 7.35 to 6.95? You're dead.
You would also, okay.
You're dead. So the common unintelligent answer, totally unintelligent, and it shows that someone really hasn't done their homework, is when someone says, oh, you don't have to worry about the pH of your blood because the body takes care of that. I mean, you can teach a parrot that, and they'll repeat that over and over and again, but that's the common response to, oh, why would you test the pH of the blood? You know why? Because if you drop from a 7.365 to 7.2, you're in an inflammatory condition which could go degenerative, and we're only talking about a 1-point movement. Now, I know it's exponential, so it's to the power of 10. So it's a lot larger than just 1 point. It's 1 point to the power of 10. It's a 10 times movement from electron saturated to hydrogen or proton saturated, from an alkaline environment to 10 times more acidic. You're in trouble. And at 7.1, you're in a coma, and at 6.9, you're dead. So what's the most important place in the hospital if they've got a brain? That's if they understand critical care, which most of them do. What's the first thing they hook up a patient to that is in compensated or decompensated acidosis, where they've checked the pH and they do this.
Like a saline IV?
That's it. Now, why would they put salt in? Because salt biochemically is one of the ingredients in combination with water and salt water and carbon dioxide, because the body, I don't know if you've ever heard this before, the body uses 90% of all the CO2 that's produced in the body from metabolism is used by the stomach to produce sodium bicarbonate every second, every minute, every hour, every day, every week, and every month of the year. So as long as you're alive and your stomach is functioning properly, the problem is the number one disorder in the world is stomach problems. And when people have stomach problems, what do they take? They take something that will neutralize the acid in the stomach. Why is there so much acid in the stomach? Why doesn't people ask that question? Why is the stomach overproducing acid? Why don't you look at yourself in the mirror and start being accountable for the consequences of your lifestyle and dietary choices? The body can't keep up with your acidic life. So guess what? The stomach has to produce sodium bicarbonate to neutralize the acids of the food, because it can't biologically transform your food into stem cells at a pH ideally, which should be at 8.4. And that's the environment of the small intestine.
So when we eat food and it goes down into the stomach,
yes,
what's the stomach doing with the food there? Or is it just like a holding tank, or it's not part of digestion? So what is it doing with the food?
It's being saturated in sodium bicarbonate. It's uptaking the sodium bicarbonate for alkalization purposes. So what the food does is the stomach will literally shower as the pancreas, as the gallbladder, and as the parental cells that line the entire alimentary canal. Even the intestines will secrete sodium bicarbonate to raise the pH so the food can be transformed into new stem cells. That, folks, cannot happen with beef, chicken, pork, or fish, because food has to be in a liquid state at a pH of 8.4 to produce healthy stem cells. Now, for Lance Armstrong, this is very important, because Lance, in order to do his cycling in the French World Championship of bicycling, right? Mm-hmm. And you already know this, you need more blood. And as a cycler, why do you need more blood?
Because there's more oxygen.
Right.
To the muscles. Yeah,
the hemoglobin is like a magnet. It takes up the oxygen. That's why he was blood doping. He would take his blood counts up from 15 to 16 up to 17 to 18. That's why he lost his honors.
Yeah, so he was taking erythropoietin, which increased red blood cell production, but he was also then adding extra red blood cells back in.
He was taking his blood out,
yeah,
and then transfusing it back into it before the big hill. What do you call that?
In the Tour de France.
Yeah, I know the Tour de France, but the mountains.
Yeah.
That section anyway. Okay, so he had more blood cells than those behind him. That's why he could sustain more, because he had more oxygen. He didn't have to do that. He could increase his blood count by knowing how to produce more blood. And it's a very simple principle. It's called the COWS program. Chlorophyll, oil, oxygen, water, salt, sunshine. Those are your 6 doctors. doctor, chlorophyll builds hemoglobin. Your hemoglobin counts go up. Your red blood counts go up when you put oil with that, polyunsaturated oils, in combination with chlorophyll, in a liquid state. All this is liquefied in alkaline water at a pH between 10 and 11 with salts. They dissolve in water. You drink this. Didn't need to dope. He could actually, and we've done this. I've done it with athletes. I coached the athletes for the 2001 Olympics in Salt Lake City for the what did they call? I think it was called the biathlon or something. I don't know. They
skiing and shooting.
Yeah, and so I coached them, and we trained up in Timpanogos, which at the base you're at about 5,000 feet, and I'd have these guys running up the mountain to 12,000 feet and running back. So from 5 to 12,000 and then 12,000 back.
That's a big run.
And you know how many liters of this concoction I just told you about? Chlorophyll, oil, water, salt, right?
You're drinking that every day?
Every day, 17 to 18 liters. They were peeing green.
Oh, gosh. And
but guess what?
Hematocrit go up?
They got stronger. They got faster. Why? Because muscle's made from blood, and the quality of the blood determines the quality of the muscle. Their ability to do more was enhanced by focusing on building blood naturally. So it's a natural form of blood doping. I thought you might appreciate that.
Yeah, why aren't more athletes coming to you for this?
They do.
Okay.
They do. Tom Brady's one.
Oh, yeah?
Why do you think he's at 44, 45 years old still playing football? You think he's drinking alcohol, eating meat? Well, yeah, he eats a little fish. But no, you can't build muscle out of somebody else's muscle. That's just drinking the blood of an animal. No, you have to build your own blood out of the anatomical elements that are found in green foods. So it's a green food protocol for building blood. But it's very simple. If you watch what cows eat, you'll get it. They have water, they have a salt lick, they have a clay lake, they have grass. They're not smoking it, they're drinking it, and so this is how you get strong and healthy. I wish I'd had this. My coach in the 60s was saying, here, take these vitamins, and what are vitamins and minerals? So, well, it's in a capsule. It's just small things that you take, and it's supposed to help you. So I thought it was weird, kind of like Space Odyssey 2000. Mm-hmm. Where a little capsule came out, for their lunch or dinner, and that was it. That's, well, yeah, it's a concentrated nutrition. So I kind of got introduced to it in the 60s, and trying to help people, alkalize. But yeah, I do work with athletes, what
do you think about breatharians?
Well, I mean, it's all part of it. I mean, breathing and breathing deeply, but just surviving on breath, it's impossible. You need oxygen. It's part of it. But what about water? What about chlorophyll for building blood? What about the membranes of cells, which are lipid membranes, that are necessary for forming, primary stem cells for producing blood? And so you can't really survive unless you have those four components in your lifestyle. So yes, I think breathing is important, deep breathing, the quality of air, but even that air has to be, reduced to atomic oxygen, O1. I mean, the cells don't thrive on O2, they thrive on O1. The body runs on electrons, not on proteins, not on carbohydrates, not on sugar. Sugar is a waste product of cellular transformation. It's a waste product of breakdown. but when you realize that salt's necessary for the transport of electrons to energize cells, at O1 is reduced oxygen. That helps to reduce acidity. That helps, life force energy because it's carrying that extra electron. So it's energizing. So that's what you need. But just living on air, no, I don't think so. It's just one of the elements that the body needs.
Hey friends, I want to take a quick second to tell you about a free, no-cost business training that I'll be hosting in April. This is a 3-day event, April 19th, 20th, and 21st, and I'm calling it the Quantum Entrepreneurship Series. And this is a high-level business training for coaches, healers, and spiritual entrepreneurs. And on the first day, you're going to learn the best types of businesses. Let's call them soul-aligned business models that you can use to fuel your mission, to create freedom in your life, to live from anywhere. I've been testing this myself for almost 9 years now, and I've interviewed thousands of people. And so we're going to be distilling all that information to show you the different ways that you can earn a living and be highly abundant as a spiritual entrepreneur. Day 2, we're going to talk about the best metaphysical practices. My favorite, I've done more than 50 metaphysical experiments in the last 5 years, and I've distilled those down into the ones that are most applicable for running a business. And finally, the last day is about infinite opportunity, how to build a world-class network, and understanding the different levels of abundance so you can bring those into your business and your life. So again, this is a no-cost series. You can sign up for it now. We'll have links below this episode wherever you're listening or watching on YouTube. And you can also go to DerekLaudermilk.com and sign up for free there, and it will send you emails to remind you exactly when that is, but they'll be at 12 Central on those dates, the 19th, 20th, and 21st. Thanks so much. Hope to see you there. I want to go back to something that was being studied when I was in grad school about 10 years ago was the human gut microbiome. And they were talking about, we found thousands of different species that inhabit the gut, this array of different bacteria. And, here we can sequence them all. And there's all these disease conditions that are associated with less diversity, and the more diversity seems to be better. What are your thoughts on that whole concept?
That theory, that concept? Well, I've in the first book that I wrote, which was One Sickness, One Disease, One Treatment, later became this book, which is Sick and Tired. I don't know if you can see it or not, but Sick and Tired. Reclaim your inner terrain. I have a section on there on probiotics, and I even developed some supplements of different strains of bacteria to help people. As I continue to do my blood research and look at the effects on that, I realized that the connection between Microzyma and organization, which precedes the genetic organization, needs to be a lot cleaner if you're going to build healthy erythroblasts that become healthy red blood cells. The concept, I don't know if we could agree on this, but I think we could, is that the bacteria that is in the 9 yards of the intestines, which is approximately 27 feet, is quite diverse. And I heard what you said, the more diverse it is, it's better. I have gone from suggesting that what is even better is not to have any of it at all, because digestion doesn't take place in the small intestine. It's the worst place for it to happen. That food should be in a liquefied state at a pH of 8.4 once it hits the small intestine, to fold into the crypts of the small intestine, to be biologically transformed into healthy, embryonic cells, erythroblasts and erythrocytes. And when that happens, this is when you see a change at the cellular level as it relates to the quality and quantity of the blood. This is why I recommend a plant-based, high chlorophyll, good, healthy, polyunsaturated oils, extreme alkaline water with pure, non-demineralized, salts that are whole salts that can be used, and even compounds of sodium, potassium bicarbonate to support the stomach. When that's done, you get a better result. So I've really discouraged those who listen to me or ask me that question, the use of probiotics, unless you're going to continue to eat foods that don't liquefy. And that's all the fibrous foods, which are not good for you. That's all the foods, the protein foods that don't liquefy and break down, which is now a doctor. His name is Dr. Pearl. What's his name? I'm going to tell you here because I just discovered his book. I had a book or an article that I wrote called "Get Off Your Acid and Go to Health," and he wrote a book. He's a professor at UCLA. He's a professor at the University of Miami. I've done some work at the University of Miami on this very subject we're talking about. But he wrote the book called Drop Acid. And I'm not talking about LSD here, okay? I'm talking about get rid of the uric acid. And that's the breakdown of a product of protein. So this whole idea of more proteins and digestion and things that are taking place in the 9 yards of the small intestine, which has a circumference area or a surface area of 7,200 square feet. And the reason I can remember that's the size of a tennis court. If you've ever been on a tennis court, you could actually lay out your intestines and cover the whole thing.
No kidding.
7,200 square feet. And in that environment, ideally, you should be producing 5,000 erythroblasts every second. That's why I don't encourage fasting. Because if you encourage fasting, you go into body wasting. And the body doesn't use, it's when you stop eating foods that build blood, then you start losing muscle and bone. Yes, you do lose some fat, okay, but it's not helpful. So I really encourage people to feast. But getting back to the question, not fast, but feast. You can eat more of the right foods less often and get a better result than depriving yourself of the things it needs, which is chlorophyll, oil, water, and salt in a liquefied form. So there's only one.
A lot of evidence for fasting for all kinds of good things.
Well, that's the perception, yes. But when you start looking at the blood, you see it's a disaster. Anybody that's fasting, you look at their blood, it's like, holy hell, what happened? But on the good side, when you're fasting, you stop all the shit that you're eating. Mm-hmm. So you've cut down on the sugar, you've cut down on the protein, and all of a sudden, that's the benefit of that. But you don't have to do it. You just cut out all of that stuff that doesn't digest because the stomach doesn't digest it. The small intestine doesn't digest it. And if you keep taking those probiotics, maybe they can help break it down because that's a possibility. But that just creates more acid that destroys the appendages, which is the root system. The root system of the small intestine are these vesicles that are coming off the intestinal villi. And they foreshorten, and this is when you have health problems because that's the root. You take roots and start cutting them off a plant, they don't flower. They don't grow. This is what people are doing by taking probiotics. They're literally creating an environment of destruction, destroying the alkaline environment of that environment, which should be at 8.4, And anything that comes into that environment should ideally have a pH between 8.4 and 9 in a liquid state. So you got a choice here. Two choices. One, you can take your steak, put it in a blender and blend it. Or two, you can discontinue taking that. Or three, you can chew it until it's a liquid state. But I can tell you get better value if you take greens, and blend those, and start drinking, rather than smoking grass, start taking wheatgrass and barley grass and hemp grass and these grasses and sprouts, and you start blending them and pre-digesting them. Because I've suggested this now, that the only instrument you have in your body to break down food is your teeth, and how you swallow it. Like if you eat, you highly chew it really good and it's liquid, or if you don't, it'll come out that same way. So if you eat a handful of peanuts or almonds and don't chew them, well, look what comes out. So much for digestion. And if you don't think it works, how about a high water content food? Take your choice. It'll come out totally intact, just like the Big Mac you eat. If you don't liquefy that, chunks of that burger, you'll chew it up, will come out in the same way it goes in. So the bottom line, no pun intended, is you have to provide a pristine environment that's free of bacteria, because there's no such thing as good bacteria. Bacteria is all morbid. It's the representation of cellular breakdown and disorganization of normality. And what you want to put in there is foundational foods for building blood in a pristine environment that's clean and pure, free of other varieties of anatomical elements or microzymas or their higher evolutionary forms of polynucleotides, which is nothing more than anatomical elements of these microzymas that organize and disorganize. Genetics is not a living. It's just an organization of the microzymas. So this is what I call intelligent microzymian reprogramming. So you want to focus on keeping up the pH. Now, how would you know if the pH was even up? Well, you have to test. And the way you test is you test your sweat, you test your fluids, you test your sweat, you test your urine. And when you're testing these fluids, you have to understand, or you should understand, that those fluids are not product of blood, they're product of interstitial fluid. And the ideal pH of that is 8.4 or higher. So anytime that the pH drops below 7.2, which it does because there's ebbs and tides of this alkalinity in our body, it's not constant. It's not just pow. Interstitial fluid is not just at one particular. It goes from, a low. Right now, the low would be, for most people on the planet, 5 to 7.5. Ideally would be 7 to 9. In other words, it would never drop below 7.2 or 7. That's if you want to live longer. If you want worldly diseases or disease, inflammatory or degenerative, what have you, then your cells are living in these higher acidic things. So what you do is you take some pH hydrant paper and you test your urine. And do it for 72 hours. Don't change anything that you're doing right now. Just eat the way you're eating, live the way you're living, drink whatever you're drinking, and then just every time you urinate, test the urine, write it down, and see what the range is. It's called the ebb and tide of your interstitial fluids. The flood time is for alkalinity is at 3 p.m. in the afternoon. The flood time for acidity is at 3 a.m. in the morning. And
that sounds like a fun experiment.
So you can do that experiment at home, and you don't have to have, a prescription for that. And I'm not giving you a prescription for it. But what I'm suggesting is you test it if you want to see if you're managing and maintaining your internal fluids properly. And that's the easiest way to do it. The treatment's really easy. In fact, it's not even a treatment, unless I guess you could classify food as a treatment. I mean, you have to eat to live or drink to live. But guess what? The body needs salt. The form of salt that the stomach's producing, sodium bicarbonate and potassium bicarbonate, all you need to do is just add those into your diet. This is how the people that lived during the time of the Spanish Flu Epidemic were up to 50 to 100 million. I don't know. You get so many different numbers, but 100 million people died from some fake phantom virus. Anyway, the way they thrived during that time is they took, and I've actually got the booklets on it from Arm & Hammer. They were promoting baking soda back then. And so take 1 teaspoon of baking soda 3 times a day. These people never got sick. Never.
Okay, so I had the experience recently, and we had to reschedule this interview because I had a cold. And I think a lot of people can probably relate to the experience of someone in their house getting sick, and then someone else gets it, and then everybody gets sick. And that creates the perception of like, I caught something from you. What do how do you explain that sort of type of transmission or the observation that we're seeing, something move through a household or a population like that?
So, I mean, most obviously, if you're in the airport and you see these people in a glass room all smoking cigarettes, and you can see the smoke in there and you're wondering why they're not all choking. And if I walk in there, I start coughing, sneezing. I mean, these are all ways in which the body tries to eliminate poisons. So there are environmental toxins or microzyma, either organic or inorganic.
Sure.
They cannot cause any specific disease, but they can create an imbalance in the internal environment. If I went into that same environment that you just talked about, I wouldn't catch anything because I don't have the terrain to catch anything. I mean, in other words, if my pH is off and I go into a toxic environment, I'm going to feel that. All the symptoms you feel that people are so-called attaching, I caught something, are nothing more than the body trying to get rid of something that's environmental through the various orifices of the body. So you may sneeze, you may cough, you may even have a nose run, even a fever. The fever is not the evidence that you're sick, it's the evidence that you're overtoxic. And that if you get bit by a rattlesnake, it's not the bite that kills, it's the poison that's transmitted into the body fluids that the body has to deal with. So not 100% of the people that are exposed to that example that you give get sick. Perfect example of that would be the Love Boat or the cruise that happened when this crazy COVID happened. Mm-hmm. Not everybody had symptoms on that boat, but they were all quarantined. Mm-hmm. And there was no way to isolate this thing, so they used a PCR test and then used some really dishonest associations that they all had some sort of something close within 70%. Well, monkeys are 96%, as far as their genetic or genome makeup to ours. But the bottom line is there's a percentage, can be anywhere from 30 to 60% that don't catch anything. And that has to do with the purity or cleanliness of the fluids of the body, particularly the interstitial fluid. So if you had a pH of your urine at 8.4 and you went into a toxic environment, everybody's sneezing and coughing, what I'm suggesting to you is you don't have the environment to catch anything. Those toxins may be taken in through respiration or from, sexual relations or from kissing or hugging. And they can be contributing factors, but they're not causative. It all comes down to individual responsibility of how well are you keeping the internal house clean. So
let me tell you a little bit more, if I can, about. So Heidi, my wife, was in Costa Rica, and she started to feel sick when she was there, developing a cough. Then she came home, and we were all feeling fantastic. And then, 5 days later, we got sick, or 7 days later, and I wasn't aware of any particular change in my diet or habit or anything like that. So it sure feels like and we're all getting the same type of symptoms. So it really.
So tell me what the symptoms were. They a dry cough or a cough with phlegm?
Like a very dry cough. Yeah.
Okay. Dry coughs are associated with radiation poisoning. So a dry cough means oxygen deprivation. It means that the cells aren't getting enough. So in the pulmonary system, the blood is coagulated together. It's not flowing into the alveoli. It's not dropping off its carbon dioxide. So the next question is, was she inoculated to go to Costa Rica?
No.
Okay, so she hasn't been inoculated.
So the situation there was, she was on this retreat, and everyone got sick. Some people tested positive for COVID because they tested everyone, but Heidi didn't have a positive test, but she still got sick along with everyone else. But we were here in the States, and we were fine. And then she came home, and we got sick. So in my mind, I'm linking, her returning with something.
Okay, so the only analogy that I can think of right now is if you take seeds and you throw them in fertile soil, they will sprout. If you take seeds and throw them on concrete, they will not sprout. So it really comes back down to, the internal environment. And for me to say, well, this is directly resulted to your wife, I would say indirectly it could be related to your wife. Mm-hmm. But I'm not denying the fact that germs do not exist in the sense of their microzymian organization, these particulates, which may be of other sources, either plant, animal, or human, they go into the environment. They can contribute to states of imbalances. So it can be a contributing factor. But the symptoms of a fever, what were the other symptoms?
I don't think everyone had a fever, but it's been this persistent, and eventually like it created phlegm, but it's like, I can hear it in my voice, it's like sitting around in the vocal cord area. And, especially at night, we get this, it's hard to sleep because we get this sort of dry tickle, right?
Yeah. So what I would suggest that you do then is if we're doing a controlled study here, I would want to have done this in advance, check all the blood parameters, check the pHs, test the interstitial fluid, and do before and afters. That's not possible. So this is after the fact. But after the fact, you still have some underlying symptoms. It still hasn't cleared up. The question in my mind is, what is the pH of your urine at the most acidic time? And that's the first urine. And then what is the range in which that urine, and that's a representation of 80% of the intracellular fluids, which gives me, an 80%, value that I can then conclude, the range from that, from morning to the next to the second urine, all the way through, to be able to see what the tides are. And you can do that for 72 hours, but don't change anything that you're doing. Okay. Then what I would suggest is we then make changes, okay, and see how fast this comes up. Because once you start changing the environment, that symptom that you is still lingering on will disappear. Mm-hmm. So I would suggest that we have an external contributing factor that may be, here again, amplified by your wife's, exposure to whatever was down there that she took in. Here again, if she's coughing and sneezing and those are going airborne, it's very difficult for me personally to get sick from that.
So you're
I'm around sick people all the time,
right?
That are coughing or sneezing, but it's a terrain problem. So I'm saying here, if the terrain is correct, you don't get sick. So there's a percentage of people that don't get sick, even when they're being exposed to airborne particulates of different microzymes.
And I was kind of surprised because I was feeling physically, more robust than almost ever. So I was like, oh, she's going to be sick and she comes home, but I'm going to be fine. So I was kind of surprised that I actually got anything just because.
Yeah. Well, here again, had we tested before she came home, okay, and got the blood parameters, all the interstitial fluid parameters, and then you were exposed to that, we could actually come down. So I'm suggesting to you that whatever the organization of those particulates, whether they're part of her or someone else, or some other thing, that can be a contributing factor, but not a causative factor. It still comes back to managing and maintaining the environment. But if you're not testing, it's hard for me to know whether that's the case or not. Other than if we have a controlled study, and I know what you're eating and what you're drinking, if that's the same, or if we alter it, or the stress, associated, or what type of, if you have Wi-Fi, is it 4G, 5G, what's the effect of the radiation? And we measure that using a tri-field meter to test the milligauss and the electrical fields. I don't know if you test those things or not to see what the environment that you live in, because, so a lot of people are standing on the cliff that just one other contributing factor, whether it was from food or water, because there's a lot of pollutants in food and water. If it's from air and and you take that in, that could throw you off the cliff. And the symptoms are not the disease. The symptoms is how the body deals with any organic or inorganic material to literally purge itself of those to maintain the cleanliness or internal purity of the body fluids at a specific pH. So that doesn't necessarily answer your question clearly, but the hypothetical is difficult when we don't have the controls at the beginning to see exactly what's going on. If you want me to describe your cough, and particularly dry cough, this is generally caused by pathological blood coagulation. Blood becomes compromised in an acidic environment, and it starts stacking, and that can lead to hypoxia and hypercapnia or carbon dioxide poisoning, and you end up, kind of choking, to try to get more oxygen. So you're coughing, but you're coughing because you're not getting enough air in the circulation. So if it was me, and this is not, a prescription, again, if it was me, what I would do is I would try to thin out the blood naturally. And in thinning out the blood naturally, you do that by eliminating all animal proteins, eliminating all sugars, and going to a green plant-based alkaline diet. I have lists of foods that you can eat freely and foods that you should eliminate on these lists. And the more pureed or the better you chew that can make a huge difference. Other things that can help is to hyperperfuse alkalinity into the body fluids, and that would be to use things that are natural, such as sodium and potassium bicarbonate. And that's what they were doing during the Spanish flu. This little pamphlet dates back to 1917, 1918, and the company that was supplying the product is baking soda. For a friend in need, I guess you're the friend in need. And I shouldn't even be playing with these. They're so old. They're over 100 years. These are over 100 years old, these little pamphlets.
That's amazing.
Here's another one here. But what they did is they took 1 teaspoon. And I'm not suggesting you do this. This is what I would do. You take 1 teaspoon of baking soda that's aluminum free. You put it in a glass of distilled water, 3 to 4 ounces. And if you'll drink that 3 to 4 times a day, you can call me in the next 24 to 72 hours and say, I'm feeling better already. Because now you're focused on not the germ, if there is one that's causing this. We don't know, but we're assuming there is one. If you start focusing on the terrain and you start peeing alkalinity at 8.4 or greater, that's going to help improve your circulation and elimination and oxygenation, and all of a sudden that cough is going to go away.
Have you heard they're starting to use this bicarbonate lotion for athletes? They put it all over their bodies before and after workouts. I've used it. It sort of eliminates that lactic acid burn from the high intensity efforts. It like absorbs through the skin.
Yeah, well, it's a lot easier. And as I like Stu Middleman, who holds the world records for ultra marathons, running over 100 miles in one day. But he holds several records, world records